So we've got two families that are coming to you to manage their investments. Family A begins saving $200 at the end of each month in an account that earns 4.2% interest compounded monthly and continues to pay into the account for 20 years. After 20 years, Family A decided to increase the amount they save each month to $300 for an additional 10 years, which is a total of 30 years of investing. Family B begins investing 10 years later than Family A. They begin their investment with a lump sum of $5,000 and contribute $150 to the account each month, which also earns 4.2% interest. At the end of each month for 20 years, withdrawing their money at the same time as Family A. Which family will have more money in 20 years, how much more, and why? And we need to describe why the investor ended up with more money. So I think it's going to take this whole page to do Family A, so I'm going to label this Family A. And what we've got going here with Family A is we're actually going to have three different formulas. So Family A begins putting $200 away each month. So that's an annuity. Then they change how much they're putting in each month to $300, which is a new annuity. And the old annuity becomes compound interest. And so as you follow me through this, I'm just going to sketch this out here for the purpose of the video. The $200 is an annuity. When they stop making payments, it becomes compound interest. They don't actually stop making payments, they change the amount that they're putting in. So a new annuity develops with the $300. And so the thing about annuities is that every single time you change the payment amount, you need to redo the formula. And what was in the account before you started changing the amount of the payments begins to grow by compound interest. And so this is going to be quite a lot of work, which is okay. So for Family A here, we've got the first annuity. They're going to be putting in $200 per month, 4.2% interest. And it is monthly, yes, so 12 months. And they have this annuity for 20 years. Then they change the amount to $300, and they do that for 10 more years. So we'll worry about that later. So our R over M is going to be 0.042 over 12. And 12 times 20 is our MT, which is going to be 240. Let's check and see if the 0.042 divides evenly. It does 0.0035. So for our Surmton, we're going to have S is equal to 200 times 1 plus 0.0035 to the power of 240 minus 1 over 0.0035. And so I need the future value of ordinary annuity formula here, because the value in this account is going up over time, paying into the account. So they are going to be putting away $200 a month. I is going to be 0.0035. N is 240. And again, I is 0.0035. So this is going to grow in 20 years to be $75,026.99. Oops. So let's see how this is asked here. Okay, we'll just answer. So this fund grows to 75,026.99. Then they change the amount that they're putting in to $300 a month, and this begins to grow compound interest. And so this will draw compound interest for the remaining 10 years. Okay. And so we're going to take that 75, and it's interesting just thinking about how much they put into this account. If we were to do 200 times 12 times 20, they put $48,000 in to make 75,000, which is pretty awesome. So this account is going to then turn into a compound interest problem. The annuity stops receiving payments, or the amount changes, and so the amount that's in the account just grows by compound interest now. And so we got 75, 02699. The rate is 0.042. M is going to be 12 still. T is, it's going to be left in here for 10 years because they were going for 30 years total time. I is R over M. N is MT. So we had 12 times 10, so 120 compounding periods for this. So let's get our compound interest formula going over here. So S equals R times 1 plus I to the power of N. We've got S equals 75,026.99 times 1 plus 0.0035 to the power of 120. And so in Wolfram here, and we get that this grows to $114,104. So this fund grows to $114,104 and 49 cents. And I might have enough room to do the last part of this. Well, probably not. I should go to the next page. So continued. What we're going to have now is we need to remember that they are changing the amount that they put into the annuity 20 years into this thing, and so it starts a new annuity. And what we did on the previous page was that we had an annuity for $200 a month, and then when they change it to be a different size payment, that annuity stops being an annuity and begins to draw compound interest. And so what we end up with is a new annuity where they're putting the $300 a month in. Still 0.042, still 12 payments a year. They're doing this for the last 10 years of their investment period. 0.042 over 12, if I remember right, was 0.0035. MT is going to be 12 times 10, so 120. So our future value of an annuity formula and so we've got S equals 300 times 1 plus 0.0035 to the power of 120 minus 1 over 0.0035. So let's go. I'm just going to click back. Maybe I'll be able to get to my original deal. Let me just check my numbers here. Still 0.42. Was that 0.0035? Yeah. Okay. So I guess we'll start over. So $300, and that's 0.0035. N is going to be 120. I is 0.0035. And so this fund is going to grow to be 44,643.94. So this fund grows to be 44,643.94. And I should take my time and write it better looking than that. So apologies for the rewrite here. 44,643.94. So we end up with two funds here, everyone. So again, starting with this page, this is the first fund that they were putting the $200 into every month. And that started as a annuity. And then when they decided to change how much they were putting in the fund, that same fund kept growing by compound interest. So we can call this green stuff here Fund 1. So that $114,104.49 there is the total amount that is in Fund 1. So it's not this case that we need to add the 75 and the 104 or the 114. We are not going to add those because the 75 grew to be 114. So that is Fund 1. Fund 2 is when they changed the amount that they were putting in to $300, that created a new fund, Fund 2. And so for total value, what we need to do is add both of those up. So total value is the 114,104.49 plus whatever is in here, which is the 44,643.94. And on my calculator, I'll swing that real fast. So 104.49 plus 44,643.94. 158,784. And I'm actually going to move some things around here so I got some more room. So I get 158, 748, 43. So total value is 158, 748, 43. And that's going to be where we end with Family A. That's quite a lot of work. And so just running through that one more time. We started with an annuity that had $200 being put into it. They changed the amount that was being put into the annuity, so that annuity stops being an annuity and becomes compound interest and continues to grow. And when they change the amount that they're going to be paying, it creates a new annuity. So this is Family A Part 2. And so I'm going to label this here as well for Family A. Family B, they wait 10 years. They start investing 10 years later than Family A did. And they begin their investment with a lump sum of $5,000, and then they contribute $150 to the account each month. And so both of those earn 4.2% interest. And so we're going to see how close Family B matches up to Family A in terms of the amount that they have at the end of this shindig. So factors to consider: Family B is investing starting 10 years later, but they are starting with a $5,000 lump sum. So it's going to be interesting who actually ends up with more money at the end of this thing. So we'll start with the $5,000 lump sum. And so they are putting $5,000 in this account. The rate is 0.042. It's going to compound monthly. And it's going to be in the account. How long are these people investing? For 20 years? Yep. So 0.042 over 12 is going to be our 0.0035 again. And MT is going to be 12 times 20, which is 240. So compound interest for this $5,000. Got a little bit of cleaning up to do here. So R times 1 plus I to the power of n. $5,000 is what's going to go in there. Let's go ahead and fill it out here before I do it on the thing. So S is 5,000 times 1 plus 0.0035 to the power of 240. I do believe that account is going to grow pretty darn good. That $5,000 over a period of 20 years is going to grow to be 11,564. Not bad. $86. So this account grows to be 11,564. 86. And so that's the compound interest part of Family B. The Family B is also going to be investing $150 a month. And so that's going to behave like an annuity. So we need to keep going with Family B here and do their annuity. This is a heck of a problem. So bear with me while I erase my old work here and bring in the new stuff. So, okie dokie. So for Family B, we also have an annuity where they're going to be putting away $150 a month, 4.2% interest monthly for 20 years. And so 0.042 over 12 is 0.0035. And 12 times 20 is 240. So future value of an annuity. So we got 1 plus I to the power of n minus 1 over I. And so we are going to have S is equal to 150 times 1 plus 0.0035 to the power of 240 minus 1 over 0.0035. So future value of an annuity going on here because the value in this account hopefully is going up for these people. And so 150 per month, 0.0035. N is going to be 240. And again for the I we have 0.0035. It was 150 a month that they're putting away, yeah? Yeah. So these folks end up with $56,000 and some change. 270.24. So this account grows to be 56,270 24. And so we need to see total for these people. We got to get what they got from the $5,000 that they invested here. The compound interest is 11,564.86. And we're going to add that to this account, which is what it is, the 56 grand. So we have 11,564.86 from the compound interest of the $5,000 plus the value in this account, 56,270.24. And they end up with 67,835.10. So total value of both accounts is $67,835.10. So family B, for family B. And so I think family A had way more, yeah. Family A had nearly $100,000 more. Family A ended up with $158,748. And family B ended up with $67,000. So to answer the question there, family A ended up with almost $100,000 more. And we need to explain why. This is because they began investing earlier. Time is fertilizer for money, everybody. And the characteristics of the investment that made that happen, they invested earlier and just made small contributions each month. And before you know it, it grows to be a pretty huge amount.